If you are watching this video, that means you have already tried learning DSA from big names, you name it. But let's be real, most of us still forgot those concepts after a week or a month. So after watching this video, I bet you won't need to watch any other tutorial because I have covered almost everything. You can check the code in my GitHub profile and don't forget to join the Telegram channel for more updates. So let's get into our video. So hello everyone, welcome back. So in the previous video, we have learned how to detect a cycle in undirected graph using BFS. So today we'll try to do it with BFS. But before going into the video, let's see what is today's insight. Solve problems by speaking out loud, just like in a real interview. Even if you don't get the solution, keep trying. Think in different ways. Recently I noticed something that's working for me. When I get stuck, even after drawing everything neatly on paper, I stop thinking about the problem and start looking at the paper. And I ask myself, what do I really need here? What's the end goal? That mindset shift really helps you. Try to inculcate this habit from next time. So let's get into the video. So in the previous video, we have understood what's actually a cycle and then we detected it using DFS. And we have figured out something like if we get any node such that if it is not parent and visited, then beside that is a cycle. Let's try to do it with using BFS. We have came to this conclusion because we have tried starting doing with it DFS. But what if we directly start with BFS? Where do we reach if we do a BFS traversal? So let's take this example and try to do a BFS traversal and let's see what we can figure it out from that. Let's take a queue. We push one into a queue and we mark this one as listed. Then we out the node 1 and we push node 2 and 4 and we'll mark this node 2 and 4 as listed. And then we pop node 2 and we push node 3 into our queue because 1 is already listed and we mark this 3 as listed. And then we pop node 4 and we see there are no nodes which are not listed. Even in this case, we have got into a similar situation, right? So we have got a node such that all the nodes are listed. So let's try with this example. So we push node 1 into the queue and we'll mark this 1 as listed. And for 1, we see only 2 as the connected node. So if we pop this node 1 and we'll push node 2 into the queue, we'll mark this 2 as listed. And for 2, we have node 1 and 3. We see this 1 as listed. So we'll push node 3 by popping node 2 and we'll mark this 3 as listed. And then we'll pop node 3 and for 3 we have node 2 and 4 as connected nodes where 2 is already listed. So we push node 4 into the queue and we'll mark this 4 as listed. And then we pop node 4 and we see for node 4 all the nodes which are connected to this, all these are listed. So even for BFS, we have reached to a similar situation where we have like as in DFS. So even if we directly start with BFS, even we can figure out the same thing which we have already figured out in DFS. That is, we need to ignore the parent node, right? So if we ignore this parent node 3, we can say we have got a node which is visited and not parent. Then we see a cycle here. And indeed, we have detected a cycle here. In this case, we see this node 3 is parent. So we can directly say there is no cycle because we don't have any other nodes which are visited and not parent. So always try to remember one thing. BFS is like front end. BFS is like back end. You might figure out the answer with DFS, but you'll know the exact process by doing BFS. Like what's happening behind. I know you did not get this. You'll understand it once I teach you for directed graphs. So let's see how do we figure out these parents. In DFS, we had an advantage like we have that tree where we can directly figure out the parent or by passing it as a parameter. But in BFS, we are using a queue. We don't know which is a parent. So we need to keep track of parents, right? How do we do that? One thing that comes to my mind is let's maintain a vector of parent. And whenever we push any element into the queue, we'll mark it in the parent vector. And that's how we figure out the parent. And also just question yourself, do we actually need an extra vector thing? Also, we don't think, what if we directly store it in the queue with the node itself, like a pair of node along with its parent? It would be efficient, right? Rather than using a parent vector. Let's write pseudocode for this. We'll call a function with adjacency list, visited vector, and current index. So what do we do in BFS? First, we'll create a queue, but for a change, instead of int, we'll store pair. We push the first node into the queue, which is index and along with its parent. But for the first index, what is its parent? So when we see this graph, for node 1, we don't see any parent. So we'll mark that as -1. And then what's next? We'll run a while loop while our queue is not empty. As you're storing a pair in a queue, we need to store it in a pair. And then we pop the first node from the queue And then we have to call neighbors, right? To call the neighbors, we need the current node. So we'll get the current node by temp dot first and parent by temp dot second. So we have got the node, then now we can call the neighbors, right? So what do we do next? If you already watched the DFS review, then you might already know. We'll have three cases here. The first one is not visited, and second one is visited and parent, and the third one is visited and not parent. This is our required case. So if it is not visited, we'll push it into the queue, the node which is neighbor and its parent. So for this neighbor, which is the parent, we are calling the neighbors from the node, right? Then the node is the parent of this neighbor. And in the second case, if it is visited and it is a parent, we'll simply continue. And if it is visited and it's not a parent, then we return 1, saying that there is a cycle present. And at the end, if we don't get any cycle, we'll simply return 0. So that's how we figure out the cycle in a undirected graph using BFS. So we started it by understanding what if we directly start this problem using BFS. Even though we got into a similar situation and we have figured out the solution step by step, and then we'll learn something like DFS is front end and BFS back end. We'll get to know about this in the next videos. And for keeping the track of the parents, we first started with vector and then we found an efficient way of storing it, like directly in the queue. Then we started writing pseudocode and we used parent here and we marked the parent of first node as -1, and then we popped each element and traversed it through its neighbors. And we have three cases here and we have figured out the solution for this question. So actually I started this series because I believe in something like if you really want to learn something, then why don't you try teaching it? Let me know in the comments like is there anything that I can improve and so that I can teach you well.